You're welcome. How are you today? How are you? So who are online? Can we say hi so we can start? Blossom Kenneth, how are you today? Good evening. Okay, hi, you're welcome. Good evening, everyone. You're welcome to today's class. So today we are going to look at simple harmonic motion, okay? So let's proceed. Buna, you're welcome. Odiba, you're welcome. Secondus, how are you? You're welcome. Please let what is on the board. Let's proceed. Blossom Kenneth, okay, you're done. All right, so we are done. I can explain. Simple harmonic motion, that is SHM, is the periodic motion of a body or a particle along a straight line, such that the acceleration of the body is directed towards a fixed point and is also proportional to its displacement from that point. Let me go again. Simple harmonic motion is the periodic motion. Once you hear this word periodic, what does it mean? A periodic is a motion that repeats itself at regular intervals. For example, the motion of a child swing, that is a motion that goes to and fro. Okay, it's said to be simple harmonic because it's also a periodic motion. Now, this simple harmonic is also an example of oscillatory motion, okay, or vibratory. Okay, so it's the periodic motion of a body or a particle along a straight line, such that the acceleration of the body is directed towards a fixed point and is also proportional to its displacement from that point. Is that okay? All right. So what do we mean by that? This is a motion of a body that repeats itself at a regular interval. So it goes to and fro. Okay? To and fro. To and fro. Okay? This is what this motion is all about. I'm going to give you examples of body that is this simple harmonic motion. Okay? Right. All right, are we done? Are we done, please? All right. All right, copy what you have on the board. All right, copy what you have on the board. Let's proceed. Osakwe done. Second is done. Odiba done. All right, let's explain. All right, we have the examples of simple harmonic motion. One is the motion of the string in a musical instrument, example a guitar. Two is the motion of the balance wheel of a watch. Three is the motion of a child swing. Four is the beating of the heart. Five is the motion of a diving board in a swimming pool. Six is the motion of the pendulum of a clock. And seven is the motion of the piston in a gasoline engine. So all this motion experiences what? Simple harmonic motion. And this simple harmonic motion is the motion that repeats itself as regular interval. So it goes to and what? Fro. To and what? Fro. Do we understand? So right, let me deep down to explain more on simple harmonic motion. Are we done? Ostakwe done, Odiba done, second is done, light done. All right, let's proceed. All right. So may be asked to write the condition necessary for body to be or to undergo simple harmonic motion. One, its acceleration is always directed towards a fixed point, and two, its acceleration is directly proportional to the displacement from that point. Okay, these are the two conditions in which the body is said to be what simple harmonic. Is that okay? Right. For Bonaya, this is not SS3. Okay, but you can join us. Okay, you can join us to learn better. Okay, you're welcome. Please give it a thumbs up, okay? Let's refill. Sorry, your messages was hidden. I'm just seeing it now. Okay, I believe it's okay now. All right. A body is said to undergo simple harmonic motion if its acceleration is directed towards a fixed point. Now, this is a circle. If this is a circle, this This is the center. And remember that this simple harmonic motion has a relationship with circular motion. So we normally use circular motion to explain simple harmonic motion. In a circular motion, is a type of motion in which the body moves in a circular path, okay, but with a constant speed. Now, as the speed is constant, the velocity is changing in a uniform manner. And as it's changing, it is directed towards the center of the circle. So, this is the center of the circle, and this is the velocity. Okay? This is also the velocity, right? Okay, so if a body says to undergo simple harmonic motion, if acceleration is always directed towards the fixed point, this is the fixed point. The fixed point is what? Is the center of the circle. That's the fixed point, okay? The fixed point is the center of the circle, and its direct acceleration is direct proportional to the displacement from that point, okay? This is my acceleration. So the displacement from this point can also be gotten from here, because the acceleration is proportional to the what? To the displacement, okay? You know what is displacement? Displacement is, we can find the distance covered. We can find the distance covered, okay, from here to here. That is what I mean by that, okay? Now I'm going to use certain equations and formula to explain this concept I'm trying to explain to you. Right. All right, are we done with what we have on the board? Let's explain better with another explanation. Are we done? Are we done? Okay, Blossom done. All right. Now, I still want to use simple pendulum to explain this simple harmonic motion. This is a pendulum bob, okay? Now, if you displace a pendulum bob, it's going to move to and what? Fro. To and fro. So it's going to repeat itself at regular interval. All right? So we have the movement of this from here to here. Okay, now this is a motion of a pendulum, right? And it's an example of simple harmonic motion. So it moves to and what? Fro. At this point, the body is at rest. Okay? At both points. Let me label it. This is what? A, B, and what? C. At points A and B, the body is at rest. Whereas at points B, the body is what? In motion. At point A and C, the body is at rest. Whereas at point B, the body is always in motion. So there are some things we should take note. We should take note that here, potential energy is maximum. Here, okay? Potential energy is maximum. Let me just say, at A, PE is what? is equals to maximum at A and what? C. PE equals to maximum, right? Because potential energy is energy at a point, okay, or energy at rest. Do you understand? Or when a body is said to be at rest or at a particular position, the energy the body possesses that time is said to be potential energy. Now, if this pendulum bob, if it is displaced, it's going to swing and go to and fro. Once you reach this highest height, it's going to, once you reach this highest point, C, you're going to return back to this point what? A. Do you understand? Okay. Now, at point B is always in motion. So we can say that the kinetic energy here is what? Maximum. So what do I mean? I mean that kinetic energy is equals to what? Maximum. And if you remember that kinetic energy is equals to what? Kinetic energy is equals to half mv what? Square, right? Now velocity is always in motion. It is what? Maximum at this point B. Okay? But at these 2 points, my potential energy PE is equals to mg what? H. PE is equals to mgh. Do you understand? So this is also an example of a simple harmonic motion when a body moves to and what? Fro. At these two ends, C and A, the potential energy is at its peak because the body will reach this certain point and then to return to the other point, okay? But at B, the body is always in motion. Do we understand? Right. All right. Loves, I'm done. All right. Are we done? So we can proceed. Joanne done, okay? Second is done. All right. Okay, she done, okay? All right, copy what you have on the board. Are we done? Light is 1 hour 30 minutes. Okay. Okay, seconds, you are done. All right, got you done. Close on done. So let's explain. Terms used in describing simple harmonic motion. The first is what? Amplitude. Now, amplitude is the maximum displacement of the body performing simple harmonic motion from its equilibrium position. Okay. All right. It is measured in meters. Period is defined as the total time taken by a vibrating body to make one complete oscillation. It is measured in seconds. That is, period is equal to total time taken over number of what? Oscillation. Now I'm going to still explain to you with a diagram what is amplitude, what is what? Period. Okay? Right. Secondus, are you done writing? I don't want that pleasantries. Secondus. Okay, let me explain. Frequency is the number of complete revolutions per second made by a vibrating body. Frequency is the number of revolutions per second made by a vibrating body. It is measured in Hertz, that in Hz, right? Now, frequency F is equal to number of cycles divided by what? Time taking. Okay? Now, I want to bring a relationship. Okay, before that, let me explain. Now, let's assume a particle is making movement. I want to explain these three parameters I just said with a diagram. A particle makes a movement. Now, this is the maximum point, the highest vertical point, okay? And we define amplitude as the maximum displacement of a vibrating particle from its equilibrium position. So this is the maximum, while this is what? Minimum. So from this middle to this highest point, it is what we say to be our what? Amplitude, right? That is my A. All right. Now, what is F? F is what? Period. Sorry, F is frequency. And what is frequency? The number of complete oscillations that a particle make in one what? Second. Okay. So this is a complete oscillation. To and what? Fro. To and what? Fro. Because the body that goes to and fro, so it's going to go and return back. So this becomes one cycle. Okay? If the body covers to and fro, this becomes what? One cycle. Then that one cycle is what is said to be what? The time taken or the number of cycles covered in 1 second. For example, the body covers two cycles in 1 second. That becomes my what? Frequency. But the time taken for it to cover this particular one cycle is said to be period. So let's assume you take this particle. 2 seconds to cover one complete cycle. It becomes what? Period. Okay? Now I can say in a nutshell that period is equal to number of complete oscillation over what? Period, let me go again. Period is equal to the time taken for a body to make one complete what? Oscillation. And frequency is number of complete oscillation made by a body in one what? Second. Do we understand? So there's a relationship between this and this. I'm going to do it in the next. I'm going to do it after now. Now, if I consider this circle here, a body that is moving in a circular path with a constant speed, that is under circular motion. If the body is moving, you make respect to what? Its acceleration. Okay? Let's assume the body, a particle is located near P. From here to the center of the circle, we have what? Radius. Okay? Now, we now move from here to here. We have another particle what? Q. From here to the center, we have another what? Radius. So you have already formed an arc. And that arc is said to be what? Theta. That's if you're making respect to angular velocity. Okay? Then the time taken for it to move around this circle is what you calculate. But then we're looking at frequency, we're looking at amplitude. The amplitude is the maximum displacement of a particle. So from here to the what? From the center to the circumference is said to be what? My amplitude. So this can be denoted as what? A. Okay? Now, if a particle starts here and make a complete oscillation, call it one cycle. The particle start here and complete this cycle and reach it becomes one cycle. So if you take that particle 1 second to make one complete oscillation, it becomes what? It becomes our frequency. Do we understand? Now, there's a relationship between frequency and period. I'm going to explain it. Let me do a recap. I said that frequency is the number of complete revolutions that a body makes in 1 second. Okay? So, and I want to use these two illustrations to explain what I'm trying to say. This is an example of simple harmonic motion. Okay, but this is a horizontal, it's not in a circle. Now, if a body moves to and fro, it completes one oscillation. Okay? An oscillation is to and what? Flow, which is what? One cycle. Oscillation and cycle is still the same. If I consider my amplitude is from this maximum displacement from here to the highest point. That is what? My amplitude. If it is given in a question as 2 meters, so my amplitude is equal to what? 2. Okay? Now, for me to consider my frequency, I have to get my cycle first. Okay? Now, the time taken for it to complete one cycle is what is said to be what? The period. But there is also a relationship between period and what? Frequency. I'm going to explain this after now. And I use this circle to do an illustration. If a particle is located here, and from here to the center you have what? Radius. This radius can also serve as my what? Amplitude. Okay? Then if this particle moves from here to rotate and meet this point again, it has covered a complete cycle. Do we understand? It has covered a complete what? Cycle, which is the same thing as this. This is half a cycle, this is the other half. So when a body do to and fro, this is a complete cycle, which is the same thing as moving in a what? In a circle. Do we understand? Right. Joan, do you understand? Secondus, okay, light. Do we understand? Do you understand, please? You will say you don't understand. Okay, I was using this two diagrams to explain the frequency, the wavelength, the frequency, the amplitude, and the period. Okay, and I said that amplitude, which is the maximum displacement of a particle from its equilibrium position, is in it. When you consider this height, the body moves. So from here, you measure this height, this becomes your what? Amplitude. We call it maximum. That is this maximum. While the down part is what? Minimum. Okay. Now, for a body to complete a cycle, you move to and what? Fro. This is half of a cycle, while this is what? A complete of a cycle. So this is to and fro. From here to here is what is said to be one cycle. Okay. Then the time taken for a particle to make this complete cycle is what is said to be period. Okay. Whereas the number of cycles a particle covered in 1 second is said to be what? Frequency. And there is a relationship between them. I'm going to explain after now. Then I now use this illustration to explain. I said if a particle is located at P, from P to the center of the circle, we have what? Radius, or we have amplitude, which is the same. Okay? Now, if this body makes one complete oscillation, you move from here to there, it has complete a cycle. It has complete what? A cycle. That is what we call one cycle. If a particle moves from point P and move around this circle and return to this point P, it has complete a what? A cycle. Alright? And that is what we have. So I'm going to explain the relationship between period and what? And frequency. Right. All right, let's proceed. All right. The period, okay, the frequency is equal to number of complete oscillation, a particle covered in 1 second, and the period is the time taken for a particle to make one complete oscillation. So there's a relationship between this and this. If you look at it, this is n over what? T, while period is t over what? N. So they are inversely proportional. So that means that the period is equal to 1 over frequency, or the frequency is equal to 1 over what? Period. Okay? Where n is number of complete oscillation. Okay? Okay, t is time. P is period, T is period, capital T is period, and F is frequency. Right. Secondus and Joan, if I want both of you again, I'm going to remove you right now. If I warn you again, you're going out. right, copy what you have on the board. Let's solve. Are we done? All right, let's solve. A spring makes 60 revolutions in 15 seconds. Find the period and frequency of the vibration. Let me do it again. A spring makes 60 revolutions in 15 seconds. Find the period and frequency of the vibration. Okay, so we go by saying the number of oscillation is 60 and the time is 15 seconds, right? They asked to find the period and we're asked to find the frequency. Now for us to get the period is equals to time taken for your body to make one complete oscillation, right? That is, what is my time? My time is what? 15, and my oscillation is what? 60. Okay? If you divide, it's going to give me 1 over what? 4. It's going to give me 1 over 4. So by the time you divide it, 1 divided by 4, the answer becomes 0.25 seconds. Okay? Now, for me to get the frequency f is equal to, I can say 1 over period, right? Okay, so f is equal to 1 over 0.25. Okay? Then I divide, and my answer is going to give me 4 Hz. Do you understand what I just saw? I said that a spring makes 60 revolutions in 15 seconds. Find the period and frequency of the vibration. Okay? What is my n? Number of revolution or cycles said to be 60, while the time is 15 seconds. They asked to find the period and the what? The frequency. Now, we remembering that our period is time taken over what? Number of complete oscillation. What is my time taken? That is 15. My number of oscillation is what? 60. So I have 15 over 16, right? By the time you divide, I'm going to have 1 over what? 4. Then which is equal to 0.25 seconds. Right? Okay. Now we have gotten this period. For us to get the frequency, we say that frequency is 1 over what? T. Right? Now what is 1 over t? My t is gotten to be 0.25. I just say 1 over 0.25 and my answer gave me what? 4 Hz. Do we understand? Right. Put it down. Let me give you classwork. What if period is not given? Period was not given. Okay, what if period was not given? It's still going to use n over t. Let me just solve another method. You can still use this method to solve for frequency. The frequency is equal to n over t, right? What is my n? 60. What is my t? 15. Okay? So when I divide, it's still going to give me what? 4 Hz. So it's either you solve it this way or you solve it this way. But what if period was not given? You're going to use this method to solve it. Is that okay? Right. Madelight, you're welcome. Blossom, do you understand better now? So are we done? Let's do classwork because I'll soon end the class. All right, are we done? Blossom done. You already done. Secondus and Juan, are we done? Odiba has left us. All right, so let's go to an example. Okay, let me give you classwork to do. All right. All right, take down the question and attempt it. Okay, I'm waiting for your answers. Now stop and send in your answers. Yes, you can. Light, you can. One point two. Okay, secondus. Okay, to 0.02. Okay. Okay, light 1.2 seconds. Blows on 1.2 seconds. John 1.2 seconds. All right. Let's solve together and see what we have. All right. Let's go. A simple pendulum makes 50 oscillation in 1 minute. What is its period of oscillation? Okay. Now, for us to solve this, the number of oscillation is what? 50. Okay. And the time, they say 1 minute. 1 minute is the same thing as what? 60 seconds, because you're solving in seconds. For us to get the period, you say that period is equals to T over what? Over N, right? Going by that, my time is 60 and my time is 60 and my number of oscillation is 50. Now by the time we cancel this, I am left with what? 6 over 5. And when I divide this, it's going to give me 1.2 seconds. Do we understand? Right. All right, we are done. Okay, so let's try another one. to try these examples. Let's see what you're going to have. Okay, well, 1 point, you're correct. So second, you solve. Are we still solving? Send me your answers. Are we done? Okay, go 45.17 seconds. Okay. Okay, will you solve it 3 times? This is like a mean. You're going to solve for the mean time. Okay, mean time, that is when we add the 3 different times, divide by 3 before you can now find your period. Okay, can I go 5.2983? Okay. Okay. All right, we solve together to see what you have. Okay. Amadila, are you sure you did not solve for only the average time? If you divide it to get your period, no, that's not what it means. That's not what it means, okay? All right, so let me solve it. Let's solve it together. All right, so a boy timed 20 oscillations of a certain pendulum 3 times and obtained 44.3 seconds, 45.5 seconds, and 45.7 seconds respectively. Calculate the mean period of oscillation of the pendulum. Now, the number of complete oscillation is 20, and we are given the first time, that is T1, is equals to 44.3 seconds. Then T2 is equals to 45.5 seconds. Then T3 is equals to 45.7 seconds. Okay. Now what you're going to do is to get the mean time. So that is the average time is equals to T1 plus T2 plus T3 divided by what? 3, right? Now what do we have? We have 44.3 plus 45.5 plus 45.7. Okay? We now divide it by what? 3. Alright? So let's add 44.3 plus 45.5 plus 45.7. So we have T average to be 135.5. I'll now divide it by 3. I divide by 3. I will get 45.17 seconds. Okay? That is my total T. Now let me get the period. The period is equal to what? T over what? N. That is 45.17 over 20. That is the period. Okay? If I divide by 20, my answer becomes 2.26 seconds. Do you understand what I just did? Now what you are going to do is to state our what? Our parameters. Get the average of the whole time. T1 plus T2 plus T3 divided by 3, okay? I will now go 45.17. So I'm working with 45.17. So my period is equal to time over what? N. I now substitute and I got my answer to be 2.26 seconds. Do you understand? Right. All right, so copy. Let's give an assignment and end the class. Okay, we have tried for today. Are we done? Are we done writing, class? Are we done? Okay, second is done. Okay, blows are done. Okay, Chi, I should go back. No, I've just concluded the topic. Okay. Okay, don't worry. When I post it, you'll be able to go back to go through it. You will understand better. Okay. All right. This is your assignment for today. All right. So take it as so we can conclude the class. Okay, secondus. You're not seeing the board. All right, we are meeting tomorrow, our normal time. I'm going to talk about the assignments so far that I've been giving you throughout this lesson period. Okay, tomorrow by 11, our normal time. Okay, all right. So, are we done? Are we done writing? Yes, you can submit it. Yes, you can. You can. All right, are we done? You're welcome, Blossom. All right, you're welcome. All right, thank you so much for staying and sticking to the end of this class. Like I always tell you and encourage you, the more you solve physics, the more you know it better. Okay, see you next time in the next one. Bye.